Students, I am very happy to meet you through this channel. I welcome you and you are watching physics class. I believe that you have watched yesterday's video. That is, we discussed about error analysis. 4 types of error analysis I discussed. Absolute error, mean absolute error, relative error and percentage error. Then I have explained about this example problem. I think you all have understood and you have practiced. Okay. Today we are going to discuss propagation of errors. Okay. Propagation of errors. What do you mean by propagation of errors? Students, when we are solving problems in physics, we will be using the formula. The formula may contain multiplication, division, etc. Isn't it? So many terms will be there in a particular formula. So, each and every measurement we will be getting an error. Isn't it? So, at last we have to conclude the result by concluding all the error analysis. Am I right? So, a particular measured quantities involve so many calculations. So, in the final calculations, we have to look all the measured quantities error. Then we have to know how to combine all those error. That's what we are dealing in this propagation of error. So, propagation of error is nothing but combination of errors. Okay. In the final result, how we will be combine the errors in all the various quantities of a measurement. Have you got an idea? Alright. So, the error in the final result depends upon individual measurements. The error in the individual measurements. Also, the nature of the mathematical operations to get the final result. Okay. So, we have to combine all these error with the proper rules. So, propagation of error means combination of errors, isn't it? So, we have to know how to combine the errors. Error in the various quantities of a measurement have to look at collectively. Then, we should combine the errors. Understand? So, while we are doing the various possibilities of combination of errors, you can understand more. Let us discuss one by one. First, I am going to discuss error in the sum of two quantities. Error in the sum of two quantities. When we are adding two quantities also have the errors. So, how can we combine the errors in addition? Understand? Let us consider the quantities A and B. So, A and B are the quantities. Quantities measured. Now, let us say delta A and delta B be the absolute errors of these two quantities. Okay. So, delta A be the absolute error of A and delta B be the absolute error of B. Okay, now we have to add, then how have to combine the errors. So listen, the measured value of A can be written as, the measured value of A can be written as A plus or minus delta A. Okay. Similarly, measured value of B. Measured value of B can be written as B plus or minus delta B. So these are the quantities to be measured. Delta A and delta B be the absolute errors. Now we can look at the sum. Okay. So consider the sum as Z. So Z is equal to A plus B. Z is equal to A plus B. Now the error in this Z, that is delta Z. Okay. Error in Z is delta Z. So we can write the error in the error delta Z. The error delta Z in Z. Okay. That is given by Z plus or minus delta Z. Z plus or minus delta Z. Understand? So, Z plus or minus delta Z can be written as Z equal to A plus B. Isn't it? So, we can write A plus or minus delta A plus B plus or minus delta B. Instead of A, we have to write A plus or minus delta A. Isn't it? And Z equal to A plus B. So this is A, measured value of A, and plus B, A plus B. So B is B plus or minus delta B. Understand? Z is equal to A plus B. This is the measured sum. Sum. So we have to write in terms of error. So I can write Z in terms of error is Z plus or minus delta Z, and A in terms of error is A plus or minus delta A. Then B plus or minus delta B for B. Now we can write A plus B as in one side, A plus B, then plus or minus delta A plus delta B. Plus or minus delta A plus delta B. This can be written as, what is A plus B? Z. Z equal to A plus B, isn't it? So we can write Az plus or minus delta A. Z plus or minus delta A plus delta B. So we can write Z plus or minus delta Z equal to Z plus or minus delta A plus delta B, or else Z and Z, if you are cancelling, we can write the error delta Z in Z is given by delta Z is equal to delta A plus delta B. So what do you understand from this? The maximum possible error in the sum of two quantities is equal to the sum of the absolute errors in the individual quantities. Understand? The maximum possible error in the sum of two quantities is equal to the sum of the absolute errors in the individual quantities. The maximum possible error in the sum of two quantities is equal to the sum of the absolute errors in the individual quantities. Understand? So delta Z is equal to delta A plus delta B. I think when you are doing the problem, you can understand easily. So let us look at the problem. Example, the resistances. You may have learnt about resistances in 10th standard. Resistances connected in series and parallel. Okay. So R1 equal to 100 plus or minus 3 ohm. This is the unit of resistance. and R2 equal to 150 plus or minus 2 ohm are connected in series, what is their equivalent resistance? This is the question. Two resistances are connected in series, what is their equivalent resistance? How will you find? I said the previous class you have to refer the 10th standard book and all. Isn't it? I hope you have learned something, you have referred something. If so, you can understand very easily. So when two R resistors are connected in series, how will you find the equivalent resistance? Can anyone tell? You may have learned like this, resistors are connected in series. R1, R2, R3. What is will be the, this is R1, this is R2, this is, what will be the equivalent resistance? So RS is equal to sum of the individual resistances, R1 plus R2 plus R3 plus etc. Am I right? So nothing but when the two resistors are connected in series, we have to add all the resistances. So this sum is explaining the addition of two quantities. Am I right? So equivalent resistance. Equivalent resistance R is equal to R1 plus R2. So I can write R1 is nothing but 100 plus or minus 3. Isn't it? Plus R2 is 150 plus or minus 2. This was given. So what is the formula for delta Z? Delta Z is equal to delta A plus delta B, or else we can write Z plus or minus delta Z is equal to Z plus or minus delta A plus delta B. Isn't it? So delta A plus delta B. This is the formula. Or else we can write this one. Z plus or minus delta Z is equal to Z plus or minus delta A plus delta B. Anyway, so here we are going to find the equivalent resistances. So we can use the symbol instead of Z as R. Okay. So R can be written as (100) plus 150. A plus B. A plus B plus or minus delta A plus delta B. So here A is 100, B is 150 and 3 is delta A, 2 is delta B. So I can write 100 plus 150 plus or minus 3 plus 2. Okay. So A plus B plus or minus delta A plus delta B. So what is the answer? 100 plus 150, 250 plus or minus 3 plus 2, 5. So 250 plus or minus 5 ohm. So this is the equivalent resistance. Are you able to understand? Okay. The two resistances are given, R1 and R2 with the error. Okay. So 100 is the R1, 3 is the error. So 100 plus or minus 3 is the absolute error of R1. 150 is the R2 and 2 is the error. 150 plus or minus 2 is the absolute error of R2. So the equivalent resistance when we are finding, that is nothing but adding the two equal resistances. So R1 plus R2. So when we are adding, we have to look into the errors of R1 and R2 and we have to combine. So obviously it is Z plus or minus delta Z is Z plus or minus delta A plus delta B. So Z is A plus B, 100 plus 150 plus or minus 3 plus 2 delta A plus delta B. So 250 plus or minus 5 ohm. Next we can discuss error in the difference of two quantities. Okay, error in the difference of two quantities. So here also the same quantities we are discussing. A and B are the two quantities. So delta A and delta B are the absolute errors. Delta A and delta B are the absolute errors. A and B are the two quantities. So how can we find the errors in the difference of two quantities? So measured value of A. Measured value of A is A plus or minus delta A. Measured value of B. Measured value of B is B plus or minus delta B. Next, consider the difference. The difference is considered as Z. So, Z is equal to A minus B. So, error delta Z. Error delta Z in Z. Z error is delta Z. So, that is given by error delta Z in Z is given by Z plus or minus delta Z is equal to A minus B. So we have to write A plus or minus delta A minus B plus or minus delta B. Clear? Now we can write A minus B plus or minus delta A plus delta B. So what is A minus B? Z. So Z plus or minus delta A plus delta B. So this is Z plus or minus delta Z. So Z, if you strike out delta Z, the error delta Z is equal to delta A plus delta B. The same previous result we got. So the maximum error in the difference of two quantities is equal to the sum of the absolute errors of the individual quantities. Understand? So what is the result? The maximum error in difference of two quantities is equal to the sum of the absolute errors of the individual quantities. Clear? We can discuss this also with the help of one problem. So what is the example given in your book? There are two temperatures given. The temperatures of two bodies measured by a thermometer. T1 is 20 plus or minus 0.5 degrees Celsius and T2 is 50 plus or minus 0.5 degrees Celsius. So calculate the temperature difference and the error in it. So they are asked to calculate the temperature difference. Okay, let's do the solution. Temperature difference. Temperature difference is nothing but subtracting, taking the difference of two quantities. So T equal to T2 minus T1. T2 minus T1. So I can write T, that is 50 plus or minus 0.5 T2 minus T1 is 20 plus or minus 0.5, isn't it? Degree Celsius, okay? The unit is degree Celsius. So while doing the difference, 50 minus 20 plus or minus 0.5 plus 0.5. So what is the answer? 50 minus 20 is 30. So 30 plus or minus 0.5 plus 0.5, 1. So 30 plus or minus 1 degree Celsius. So this is the temperature difference and their error. The next one is error in the product of two quantities. Error in the product of two quantities. Okay. So here also we will be taking A and B are the two quantities. Delta A and delta B are the absolute errors. Okay, delta A and delta B are the absolute errors. So what is the product? The product is taken as Z. So Z is equal to what? A into B. Z is equal to A into B. So the measured value of A is A plus or minus delta A. Measured value of B is B plus or minus delta B. Isn't it? Measured value of A is A plus or minus delta A. Delta A is absolute error. Similarly, measured value of B is B plus or minus delta B. So what will be the error? The error delta Z in Z is given by Z plus or minus delta Z. Error delta Z in Z is given by Z plus or minus delta Z. So Z plus or minus delta Z is equal to what? Product of two measured values. So A plus or minus delta A into B plus or minus delta B. Am I right? A plus or minus delta A into B plus or minus delta B. So how can we simplify this? A, this is the multiplication. So we have to multiply this quantity with these two as well as this quantity with these two. Am I right? So we can write AB. A into B. Then A delta B. So plus or minus A delta B. Then delta A into B, or else we can write B into delta A. Then plus or minus delta A in delta B. Ordinary multiplication. A plus B into C plus D. So AB plus A delta B. Here plus or minus. So AB plus or minus A delta B plus or minus delta AB. That is B delta A plus or minus delta A into delta B. Understand? Here now we are doing some simplification. That is dividing both the sides by Z. Dividing left hand side and right hand side by Z. Z or AB. Okay. So what we will be getting? Z plus or minus delta Z divided by Z is equal to, here the whole term, AB plus or minus A delta B. So here also AB by AB we can write. Z is nothing but AB. So AB by AB plus or minus A delta B by AB plus or minus B delta A by AB plus or minus delta A B by AB. Delta A delta B by AB. Okay. So this side, that is left hand side, we are dividing by Z. Right hand side we are dividing by AB. So this is for left hand side, and right hand side we are dividing by AB. Z equal to AB. So here Z get cancelled. So what will be getting? 1 plus or minus delta Z by Z equal to AB cancelled. 1 plus or minus A cancelled. Delta B by B plus or minus B cancelled. Delta A by A plus or minus delta A delta B. Delta A by A, delta B by B. Delta A delta B by AB. Understand? In this equation, this delta A by A and delta B by B, the fraction, this is very small. Okay. So error even very small. So we are taking this product, the fraction error, that also very small. So we can neglect that term. So this product delta A by A into delta B by B, this is very small. So we can neglect. So remaining 1 also we can get cancelled. So delta Z by Z, that is 1 minus 1 equal to, so delta Z by Z is equal to delta A by A plus delta B by B. Here we can write plus or minus. Delta Z by Z is equal to plus or minus delta A by A plus delta B by B. Understand? So this is the error in the product of two quantities. Are you able to follow? I think you have got it. So we are multiplying the two quantities A and B. A is getting the measured value A plus or minus delta A, and B is getting the measured value B plus or minus delta B. So we are going to multiply AB. So error Z plus or minus delta Z is equal to A plus or minus delta A into B plus or minus delta B. So just ordinary multiplication we are multiplying, and we have got AB plus or minus A delta B plus or minus B delta A plus or minus delta A delta B. Here for simplification we are dividing the left hand side by Z and right hand side by AB. So the simplified term will be getting 1 plus or minus delta Z by Z is equal to 1 plus or minus delta B by B plus or minus delta A by A plus or minus delta A by A and delta B by B. So this term is very small, so we can neglect, and 1 also we will be getting 0. So delta Z by Z is equal to delta A by A plus delta B by B plus or minus. So the maximum fractional error in the product of two quantities is equal to the sum of the fractional errors in the individual quantities. The maximum fractional error in the product of two quantities is equal to the sum of the fractional errors in the individual quantities. Understand? Okay students, today we have discussed about the propagation of errors, that is how can we combine the errors in a final calculation of a measured quantity. So first we have discussed the errors in the sum of two quantities, next error in the difference of two quantities. We have explained two also with examples, and last I explained about product of quantities, the error how can we obtain. So error in the product of two quantities. So for this product of two quantities, tomorrow we can discuss about the example problem. Okay, learn well students. Thank you.